cover as much territory as possible for you to get maximum benefit. Questions? All of you good? Yeah.
Normal concrete. Then chloride have effects or not?
If you don't have reinforcement, don't even bother. Put whatever you want. If you typically in the US, that's what they do. Accelerators for cold regions. If you are doing concreting in cold weather, you put in accelerators, right? So if you do a pavement with no concrete, if you do a driveway with no reinforcement, chloride-based accelerators, which are very cheap, nothing but calcium chloride. You just get calcium chloride, very cheap. You throw them in, heat of hydration goes up. There's a lot of chlorides in concrete. Nobody bothers. You don't have to bother. Very intentional. You have right. That's why I said accelerated construction for cold climates. Certain time will increase, and that's what you want in cold climates.
Sir, our concrete is not that much durable, but Roman concrete was durable for a long time, and they used only that aggregate, that time local aggregate, pumica or something, and sea water and volcanic ash. So how it got durable that long time?
So different things that you have to consider, right? They cured concrete for tremendous periods of time. Their concrete was very, 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 very slow strength gain, which means the effects of microcracking, because all the accelerated hydration was not there. And even if they ever got into some way of such cracking, the enhanced curing that they did accounted for that. The loads in those structures were a fraction of what you subject your structures to now. They were thick, they were over-designed, way over-designed for the loads that they were supposed to carry, because they didn't have any way to calibrate and calculate what they are. So they were never optimized. Right? So all of these conditions, yes, they stand for a long period of time. So if you don't want your concrete to be used for 6 months, and you don't want any strength gain in the first 14 days, you can make super concrete. But then if you're putting a concrete highway, can you tell them, I'm doing the concrete now, I'll try to open it after a year. And make a bridge deck now, yeah, drive after a year. Possible? No. Even a simple thing as building a house. I am doing concreting for my house. Typically, I'll try to hand over the key to your house after a year, because I'm going to cure this forever. It's not happening, right? So we have accelerated all our processes, and anything that you accelerate, you will have issues. The cements that the Romans used was not the Portland cement that we have now. It is not what is manufactured under these conditions now, right? So it is not a product where you have manufactured it to design your short-term needs. It is something that they know will sit and harden forever, because somebody told them that will happen. That will happen. What did they use for air entrainment in those days? Their air entrainment for freezing and thawing in Roman concretes, when they have the air entrainment, nobody has such nice spherical distributed spheres, and they have absolutely no freezing and thawing problem. What did they use? They use blood as an air entrainer. Can we use blood now as an air entrainer? No. So the materials have changed, the technology has changed, and we are all possible. So we don't have time to wait for all the things to happen before you expose it. So a lot of microcracking happens. You say 7 days I'm opening this bridge to traffic. Between day 7 and day 28, massive microcracking is happening in that bridge, because it hasn't gained enough strength. And I told you the same idea. You only need a localized place with a low porosity, with a lower elastic modulus to give you a localized higher stress to start a crack. None of us can guarantee that billions of those are not present in all of our countries. Right? But if you don't subject them to load, those microcracks are not going to form. If those microcracks are not going to form, the cracks are not going to get larger. If they're not going to get larger, moisture and chlorides are not going to get in. You don't have corrosion.
Are there any recently developed methods for designing high performance concrete?
There are a lot of new methods for this. Actually, it's not new, the right method. And a lot of people are doing it now. The right method, so the method for high performance concrete, I mean, if you read some papers 10 years before, they all talk about HPC, high performance concrete. What did they use? 800 kilograms per meter cube of cement. That was our definition of high performance. Why? High performance was immediately related to high strength. High performance is not about high strength. High performance is about high strength and high durability. So higher strength will never ever ensure you a higher durability.
Yes.
Right? We've explained last 2 days, we've spent the entire time explaining what happens with the creation of pore structure and the microstructure that influences both strength and durability. So the actual and the best way to create a high performance concrete is to really optimize all your particles so that your gradation is beautiful in such a way that the share of the larger particles, the pores that is created by those larger particles are filled by the smaller ones, further smaller ones, further smaller ones, and water is only a mediator, not a major player in the story. Water mediates a reaction and not takes over space and evaporates later.
But in the current scenario, which method you will recommend for designing HPC?
What do you mean, which method?
Any method apart from PC Edson's developed method.
Apart from?
PC Edson, who is...
PC Edson's method, so those are all very generic methods. Right? I know. His method always very similar to me, telling that your concrete has to be very dense. And you get density by packing the aggregates and packing the particles in such nice form so that you use as less of cement. But to your point, the other thing that has to change if you want to have really durable high performance concrete is for specifications to change. No agency should say that because you have a high performance concrete, give me 500 kilograms per cubic meter of cement. Your agency should stop saying that. Right? That's what the first day I told you. Specifications for good concretes have to move away from prescriptive to performance. The moment you tell somebody, and the only people who are happy when somebody says they want 500 kilograms per meter cube of cement are the cement companies. Nobody else is happy. They're happy. And actually, if you talk to some smart engineers in cement companies, they're also not happy. And they have to do it because it helps their bottom line. But realistically, what should happen is, why should there be a limit on 25% of fly ash? Why should be there a limit on these numbers? Well, if there are chemical characteristics of fly ash that you know will contribute to durability issues later on, absolutely yes, you should have a limit. But a limit based on strength is just not acceptable. Because like I said, strength is not something that everybody gets. If you say that elastic modulus, I'll agree to it. But strength is not something that I and he and you can get the same way. It depends on how we design it. So you can get strength whichever way, and then you should leave that to the designer to say, give me this strength, satisfy this performance. So in the US, there are performance related specifications for concrete pavements. A lot of states are doing it. So performance related specifications plus, no, performance related specifications just can't be on one side. Performance related specifications always have to tie in with contractor incentives and contractor penalties. If that is not there, it doesn't work. You create give the contractor an incentive, right? Give me this strength, give me this durability, they give me this roughness of the pavement, show me that the pavement can, through laboratory and accelerated tests, last this longer, and construct 1 mile of pavement 10 days before your schedule, we will give you 10% extra money. That incentive. Contrary, you miss 3 out of 4 characteristics, you will get nothing for the pavement that you've placed because we have to pay somebody else to dig that off. Therefore, the advantage number 1, only a contractor who is capable and confident of doing the job will come forward. You remove all the contractors who came out just because contracting was a lucrative business, right? Your contractor will be forced to employ engineers who actually know the stuff. Your contractor will be forced to test properly everything before he starts implementing it in the pavement or in the structure. Now, an ecosystem starts to develop where they are feeding off of one another, and a new guy, if he wants to be a contractor, will take the effort and the time to get trained and get certified. Now see the benefits of that happens. All because in the US it's very stringent. If you screw up one job, you are bankrupt. You can't do anything, that's it. Because think about it, right? You take contract for 25 miles of concrete pavement. You have deadlines. You don't deliver. You deliver bad concrete. You lose 50, 100, 200 million dollars. Where are you going to get it from? That's it. That's what he would have earned in his entire life by doing business. His company is bust. So only good companies will enter the fray. And because there is a lot of work and you see this lucrative thing happening, a lot of people will take the pains to go through, learn the right stuff, get certified, establish a testing lab, make sure that quality control procedures are totally spot on, and be willing to help collaborate with universities, other industries to take the technology forward. So in the US, it's all these pavement companies, you come up with a new method to measure the depth of a concrete pavement. So there is something called mid-scan. I know if you're doing concrete pavements here, that's something that you should look at, mid-scan. That now gives you the depth profile of a pavement to 1/100th of an inch accuracy. Because concrete contractors are paid based on the thickness of the pavement, right? Because you can't. Now, what you used to do before? You used to drill cores. You can easily mess up with the system of drilling cores. If the engineer who comes to supervise drilling cores is my friend, I will tell him where to drill the cores, right? Right? Which means you can game the system. When 12-inch, again think of it, 12-inch thickness concrete is specified for the pavement. Think about how much money a contractor can save if 1/2 of a 25-mile stretch he reduces the thickness by 1 inch. How much money he can save in concrete? 8%. So much, right? Now, mid-scan, nobody can say because you're putting it in the bottom of a truck and driving through and you get the profile. Every point you know what it is. Of course, there are tolerances and you know, but an inch is not a tolerance. 25 mm drop in the reduced thickness is not a tolerance. That's an error. Right? There's a difference. So a lot of times we also make a mistake of mixing tolerances and errors. We say you make an error and you try to show off that as a tolerance problem. I've seen that so many times. Right? But there's a difference between error and a tolerance. So now you get these advanced. So the contractors now, the good contractors are so very interested in using these technologies, and they are the first ones to embrace it because that helps them to get paid money faster. Now think about a contractor who is doing $50 to $100 million of a work, and think about the advantage of him getting this $50 million a week ahead of time. Right? A week ahead, which means they're all rolling money from different things, right? They have projects, they take money from one, they will take loans, they do all this. Think about the advantage of getting money a week or 2 weeks ago. All of these adds up into their incentive in making the concrete better. So now what happens is you create an ecosystem where everybody is interested in making the concrete better. Everybody is interested in getting this better. Nobody wants to be the guy who is called the guy who screwed up this project. To give you an example, Denver Airport, new airport in Denver in Colorado, they have created a new airport and they built completely new runways. There was a contractor who was supposed to do all this concrete, and to cut corners, he was supposed to get aggregates from place 50 miles away because Denver is very notorious for alkali silica reactive aggregates. So he was supposed to get 50 miles aggregates from 50 miles away, but he or somebody screwed it up. For some section of the airport pavement, they got local aggregates and the local engineer didn't see oversight. In 6 years, the pavement started massively cracking. But there was a clause in this contract, and that's how most of these contracts are written, for very big, huge projects, that the contractor can be liable for a longer period of time. And he was liable for a longer period of time. He had, with his own money, dig in the entire section of the pavement, 2 or 3 kilometers of pavement on the taxiway where this happened, dig with his own money, replace with his own money, and pay the airport of Denver a penalty. That's the level of quality control and that's the level of accountability. Here, if it's here, you wouldn't find the contractor. He would have gone a long time ago, made the money, moved on. And that's the reason why you should have good quality contractors, good quality concrete producers who will stay on the job, whom you can trust. It's not, fly-by-night. We call them fly-by-night contractors. People who just show up one day and you don't see them after that, fly-by-night. These are not fly-by-night contractors. These are people who, and they are the first ones to embrace. Have you seen you saw yesterday in Mr. Srinivasa's presentation the concrete paver, big concrete paver, right? They were the first ones. The American contractor was the first one to embrace those paver technologies. Because why? It's easy. And if you see a car, okay, another thing. If you want to see a concrete pavement job being done, okay, there will be about 6 people in site all together. That's it. That's it. 6 to 10 people in the site. Productivity, because it's all mechanized, and the control, there is a lot of quality control tools going on. They measure, he talked about maturity method with sensors for all this strength development. It's all maturity control. System is much more robust. We can get there, absolutely. We have the expertise, we have the people, we have the quality, we have the infrastructure. The only thing lacking is trying. We can absolutely do it. There is absolutely nothing that stops us from doing it. And many of the concretes that are being done in some of these highways, I was told, was really, really good. So we can do it. But we have to translate that and extend that to the entire business. That's the application part that we have to do. Any other questions? Okay, so I hope that all of you would have gained something over the last 5 days. Yes.
I think whatever you told earlier, you don't like recycle aggregates because of some, sulfate.
If you have, it's not about I am not liking. Okay, I am nobody in this show. Okay, it's not about my liking. When I say I don't like, is I don't recommend recycled aggregates if you have a source of natural aggregates. If you have to use them, then you have to use it based on how you select them, and then be willing to take the risks associated with a bad quality recycled aggregate. As in any case. Okay, I have no personal likes or dislikes.
No, you will not recommend that recycle aggregate is coming from some agricultural environment. Already it is there. Then we are not using recycle aggregate coming from agricultural environment. We are checking all the parameters. So, what is your solution or what is your suggestion on?
I don't know. What is my suggestion? Use good aggregate. So you're putting me in a spot by asking that question. Because whatever I say can be interpreted in whatever way people want. So my solution is, if somebody wants to use recycled aggregates, please use them. Be careful in making sure that that recycled aggregate is not deleterious. If that is deleterious, fair enough, be prepared to dig it out and put a new one very soon. But you cannot have, again, remember, in terms of a bad aggregate, especially a bad aggregate that's likely to cause expansion, you don't need too many of them in your concrete to spoil it. Right? You can get local expansive stresses, local cracking, and when you have local cracking and local corrosion, then steel is connected completely through, that happens completely through. So you don't need too many aggregates to create a problem, and that is where all of these, or 99 of my 100 loads of aggregates were good, just one is bad, that one is enough sometimes. So it's not about a solution, it's about being careful about the type of materials that we use, being careful about the type of, I've always heard this, right? We don't even have enough water to drink. How are you suggesting me to wash the aggregates? Very, very practical question, yes. So when you say that aggregates have to be clean for certain purposes, how are you expecting me to wash aggregates? Very true. That's a limitation. That's a limitation that we have. So what do? If you have a situation where you want to build a structure and you have only bad aggregates and you have no local supply, talk to a ready-mix producer to see if he can get you good concrete. If that's not available, talk to a precast producer to see if he can prefabricate slabs from somewhere and give you. Right? Rather than knowingly putting really bad concrete. And if you're putting sidewalk, driveway, some support structures, it's okay. But structures that you want to last for 50 years. Or you can say that, yeah, my aggregate was bad, my concrete supply was bad, my water was bad. Doesn't matter, I want this concrete only to last for 5 years. Then this totally good. It's up to you. But I am talking about a concrete that is supposed to last for 30 or 40 or 50 years. Right? No.
For this heavy amount of recycling in India, we done I think 25 to 30 million ton recycling is produced per production. So want to do huge amount of
use road bases. You have plenty of roads being built. Use recycled aggregates as bases for roads. You don't have to necessarily put every piece of recycled aggregate in concrete. Use it for road bases. Use it for treated road bases. They'll happily stay there. Right? So use it for applications that are less critical in the long term. Right? Use it for mine filling. You have a lot of unreclaimed mines that have been mined all over the country, and the mine shafts are still. Use it to fill those mines. Use it to fill the mine holes. So use it to do something that it can very well do without causing problems. What is your and this is something that I ask people. What is your necessity that every waste material will have to go into concrete? Why is that? Why is that everybody is so intent on putting every waste material into concrete and then telling us if this is the greatest thing that has happened? Would you put a lot of waste materials in your backyard at home? You wouldn't, right? Why should your concrete have all the waste materials? If the waste materials can synergistically do things that make the concrete better, by all means, yes. If the waste material can sit down quietly inside concrete, by all means do it.
Still okay.
Huh?
It is still okay.
It is still okay. It doesn't have to help. It should not hurt. Just come in, sit inside, fill my space, move on. Fine, do it. I'll tell you a story. While I was studying Madras, it was all recycling. This was a big thing there. So one of these professors was big on throwing everything into concrete. So he used to make these BTech students come in and make all this. So they used to go to hostel rooms and faculty apartments and collect all this plastic waste and stuff to put in concrete. And one day, and they made some traffic barricade blocks to do dividers of roads and stuff with concrete. So one concrete had even a shoe in it. It was all waste material. You come, dump in everything in it, put in a bunch of cement, you make concrete, you have a shoe in it. Yeah, great. So, and you put it as a divider. So one of the mechanical engineering professors was coming apparently in the night. I don't know if it's completely a story or partly a story. But I think it's partly a story. One of the mechanical engineering professors was coming in the night in the campus, and he didn't see this divider, so his car hit the divider and it broke because it had shoe in it. Very weak. And the shoe popped out. He called the other professor and says, "You guys doing concrete are so crazy. What are you trying to do? You're putting even shoes in concrete?" Right? So, our aim has become, and you see this, in the name of sustainability, throw in anything that you can get into concrete. A sustainable concrete is a concrete that will last long enough. A sustainable concrete is not something that you throw your waste into. And there are journals of sustainable construction that you can write whatever and submit and they'll accept. And then you think that my job is awesome because the journal accepted. For every one guy who is thinking your job was awesome, there are 15 people sitting and laughing around. Okay? So, but since you're not seeing it, that's okay. Don't try to use concrete as a sink for your waste materials. It is not. It is not designed for you. It's a structural material wanting to do a function. If you don't let it do its function well, don't hurt it from doing its function. So if you have something that's totally inert, so people put recycled tire in concrete, I have no problem with it. It just will stay there. You make your concrete softer, or may I say soft, less stiff. less heavy. If you want it, that's fine. A certain amount of recycled tires, fine. But don't put in things just for the sake of putting in a waste material. I have a waste material from a local source. What do I do with it? First question. So now, therefore, you will see people in chemical engineering, people in mechanical engineering, people in physics, people in waste management. Everybody is doing concrete these days, right? Because it becomes such an easy material. Because what do you do? Oh, cement companies, easy, you can get cement. I know, I looked up some paper and said concrete is a mixture of cement, water, sand and rock. Great, I know all of these. I have rock, I have seen this rolling around. I have sand, I know it, I have it. Cement, I know where to get it from. Water, I have plenty in my backyard. And then I have a bunch of waste, I'll put it together and make my concrete. And then they publish in some journal, and there will be mechanical engineers who will know nothing about concrete. There will be chemical engineers, there will be physicists, there will be people who are running around in the field. Everybody is a concrete technologist. And then you have no shortage of concrete experts in this country. Okay? Absolutely. Everybody knows concrete, everything about concrete, which is actually good. I'm very proud because everybody knows everything about concrete. It's great. But that should not lead to mistaken notions and mistaken ways in which you use the material. This is, again, if you don't take anything away from this 5 days, I want to take away one thing. You are dealing with an engineered product, not a commodity material. Your ready-mix concrete supplier wants you to think that concrete is a commodity so that he can supply it. Okay? But that he can think it's a commodity, but as a receiver and as an engineer who wants the product to perform to a certain level, it should not be a commodity product. It should be a designed, engineered